Look, Aunt Martha, men just don't get into window seats and die.
Oh, no, dear. He died first.
Yeah. Oh, wait a minute. Stop all this. Now, look, darling, how did he die?
Oh, Mortimer, don't be so inquisitive. The gentleman died because he drank some wine with poison in it.
Well, how did the poison get in the wine?
Well, we put it in wine because it's less noticeable. When it's in tea, it has a distinct odor.
You mean you...
Are you concerned that the kindly old ladies from down the lane have secretly spiked your wine with arsenic? One way that you can quantitatively measure the amount of cationic arsenic 3+ hiding in your glass is by adding an anion that forms an insoluble salt. Sulfide, for example, combines with arsenic to produce arsenic sulfide, which has a solubility product of 2.8 times 10 to the negative 72. Remember that sulfides are a bit of a special case. The sulfide ion S2- is a strong base, so instead of the equilibrium product you'd usually expect of arsenic sulfide and water in equilibrium with 2 arsenic ions and 3 sulfide ions, the sulfide quickly reacts with water to create bisulfide and hydroxide, and the overall equilibrium reaction is arsenic sulfide and water in equilibrium with 2 arsenic ions plus 3 bisulfide ions and 3 hydroxide ions. So if we want to measure the amount of arsenic in our glass of wine, we can run the reaction in reverse to drive as much of the arsenic into arsenic sulfide as possible, and then weigh the result. According to the balanced formula, the solubility product relationship is 2.8 times 10 to the negative 72 is equal to the concentration of arsenic squared times the concentration of bisulfide cubed times the concentration of hydroxide cubed. So we can see that the solubility of arsenic depends on the concentrations of bisulfide and hydroxide. The higher the concentration of those ions, the lower the concentration of arsenic goes in order to maintain the solubility equilibrium constant. It also means that we drive equilibrium towards the solid salt, and the better our final measurement of the arsenic concentration will be. So if Cary Grant were to have performed this reaction in 1944, he would have added sulfide by bubbling hydrogen sulfide, or H2S, through the wine to create a saturated solution around 0.1 molar of H2S. Hydrogen sulfide is a weak acid, so it doesn't just dissolve, but it reacts with water to produce hydronium and its conjugate base, bisulfide. Wine itself is already acidic at around pH 3.3, and for the purposes of this example, we'll assume that the other molecules in the wine buffer it well enough that the pH remains constant. The acid dissociation constant for hydrogen sulfide is 9.1 times 10 to the negative 8, so that means that the concentration of hydronium times the concentration of bisulfide divided by the concentration of hydrogen sulfide is equal to 9.1 times 10 to the negative 8. And since we already know the concentration of the hydronium from the pH and the concentration of the hydrogen sulfide, because we've said that it's saturated at 0.1 molar, then we can calculate that the concentration of bisulfide must be 1.82 times 10 to the negative 5 molar. And for hydroxide, we can also use the pH and the autoionization constant of water to show that the concentration of hydroxide is 1.995 times 10 to the negative 11. Substituting these values into our solubility product gives us 2.8 times 10 to the negative 72 equals arsenic squared times 1.82 times 10 to the negative 5 cubed times 1.995 times 10 to the negative 11 cubed. Or that the concentration of arsenic under these conditions can be at maximum 2.42 times 10 to the negative 13. So however much arsenic was in the glass to begin with, only 2.42 times 10 to the negative 13 molar can remain once we've saturated the glass with hydrogen sulfide. In a 5-ounce or 148 milliliter glass, that leaves a maximum of 2.7 times 10 to the negative 12 grams of arsenic dissolved. According to the CDC, The minimum lethal dose of arsenic is 50 milligrams. This method would extract all but the tiniest fraction of that amount, letting you know if your hostesses are really as benevolent as they seem.
You know all about it and just forget about it. I do think that Martha and I have the right to our own little secrets.